thank you. Okay, so Multiple is a collaborative project funded by the European Commission under H2020. We are in the third year of the project, and the main aim is to develop a multispectral, scalable monitoring solution for optimizing different processes. The main target technologies are these three kind of spectral sensors. So we are developing Snapshot hyperspectral cameras ready for volume production, organic electronic-based microspectrometer, so very cheap solution with no moving parts, no diffractive optics, ready for material sensing, and finally laser-based spectrometer for gas sensing with very high sensitivity. On top of that, we also develop an edge cloud infrastructure to allow the translation of the raw sensor signals into valuable parameters about the process. So regarding the novelty of these snapshot cameras, so the main difference of a hyperspectral camera with respect to a normal RGB camera is how they sample the spectrum. So instead of having three wideband channels like RGB, these hyperspectral cameras sample the spectrum in very narrow and contiguous band. So instead of 3 channels, we can have tens or hundreds of channels. And we create this hypercube or chemical image. So for each pixel, we have the spectral signature, which is different from different materials, and we exploit this information to obtain chemical information about the composition of the material. So there are different technologies to implement hyperspectral cameras. The standard ones use any kind of scanning, so we need a movement of the material with respect to the camera, or we need to perform the scanning in the wavelength domain. The cameras developing Multiple are using spectrally resolved detectors that have the filter on top of the chip, so we can create a hypercube in the same instant without diffractive optics. So these kind of cameras have intermediate spectral and spatial resolution, but are really compact, reducing the cost, and allow the acquisition of the images without moving the object. So with these sensors, we cover a wide spectral band from the visible to the far infrared. And with this information, we aim to extract different parameters about the processes and product like composition, texture, color, shape. We are targeting 3 different areas in the project: steel manufacturing with a rolling mill, woodworking with a furniture manufacturer, and in the food industry with a chocolate producer. So in this case, the end user is Yotis, which is one of the major food companies in Greece, and they have a really wide portfolio of products, from baby food, bakery products, chocolate, or dessert. Just a showcase application we are working here in Aymen is the evaluation of the glossiness of the chocolate sprinkles. So these sprinkles are used to decorate cakes and dessert, and it's really important to have a really good visual aspect. So the final step in this process is the panning, where these sprinkles are placed on big tumbles, rotating, and there is one operator that supervises the process and provides different coatings to this chocolate until they reach the optimum stage, final stage. So this is done visually at the moment, and what we try to do in Multiple is to have an automatic system to check this glossiness. For that, we address this as a classification problem, where the operator would put this sample on this kind of light cabinet, and it will automatically classify the sample in 6 different stages of the process, depending on the glossiness. We have done some experiments at the laboratory here in Nijmegen, so Jotis provide us a complete set of samples using different chocolate mixtures and with different glossiness from different production stages. We collected some data sets using a hyperspectral camera developing the project in the visible range. And yeah, we can see that the spectra is quite different depending on the production stage. However, in order to obtain a more robust classifier, we also want to exploit the texture of the images, which is very characteristic on these samples. So we combine a texture descriptor together with an SVM to perform the final classification. And from this preliminary test, we obtain 100% accuracy in this dataset. So we think this is very promising and we are reaching good discriminating capabilities.